Thank you very much for that nice introduction. Ladies and gentlemen, it's really a pleasure to be the final speaker of a wonderful evening. This has been a fantastic event. I hope you have all enjoyed it as much as I did. Have these fantastic speakers here with us tonight, this showcase, if you will, of applied mathematics. Just this demonstration of what mathematics can do and does accomplish in the real world. It's a fantastic story. And so it's really a pleasure to wind up. And I'm well aware of the fact that I am now the only person between you and a drink. So don't worry, I will be brief. But you will forgive me for just expressing that pleasure, for finding so many people interested in mathematics, practicing mathematics, possibly both, all in one hall. It's a very special occasion. One colleague of mine a long time ago told me that he gave a lecture on applied mathematics in a soccer stadium with 60,000 people listening to him. That's hard to beat, but we're getting close and we're moving in the right direction. I was asked, among other things, to summarize what this evening has learned us. That is not an easy question, but in a way it is, because the summary is, in a way, what is written there. Mathematics is a miracle, a true miracle. And I'm going to say a little bit more about what makes it so miraculous as we go forward. But before we get to those miracles, there is another miracle that I want to draw your attention to, which is the miracle that SIAM is here in the Netherlands. And that is not self-explanatory. If you look at this map, you will see there were plenty of alternative countries to go to. And nevertheless, SIAM is here. We should count our blessings, and let me welcome all the SIAM participants to the Netherlands once again. But so there are so many alternatives, and you might wonder, why is SIAM here in the first place? And there is, to those of you who know, an unfortunate resemblance to the way in which the World Championship soccer moved to Qatar. Not a parallel and a metaphor to be particularly proud of. I want to reassure all of you here that there are very solid reasons for SIAM to come to the Netherlands to organize a conference on applied mathematics. Because the Dutch have a distinguished track record in applied mathematics. And I just want to spend a little time on that track record. So what I'm going to do is give you a sample from this, one of my favorite books in my library, the book of famous Dutch applied mathematicians. And if you are impressed by the volume of this particular book, let me assure you of one thing: it is much, much thicker than the book of famous Qatar soccer players. So what I'm going to do is just sample a few pages from this huge book, so as to convince you all that SIAM is here for the right reasons, and also to make the Dutch here feel a little bit proud of their country. So here are a few famous Dutch applied mathematicians. Just very quickly, the first one is here René Descartes. He was an inventor of algebra, and he lived in Amsterdam around 1630, roughly, and in fact he lived on the Kalverstraat, a street that I recommend to all the non-Dutch here for a shopping excursion. It's not far from here. You may think that Descartes was French. But let me say this: if the French claim that Vincent van Gogh was French, then I think we can claim that Descartes is Dutch. So let's claim him here and now. First example. Second example. Equally famous, I would say, Christiaan Huygens, a name that only the Dutch can pronounce correctly. Christiaan Huygens, a colleague, a contemporary of Descartes, of Newton, multi-gifted person, the inventor of many things, but also of the pendulum clock. You see it here. And interestingly enough, its use as a navigation device on ships. And Huygens had a very interesting career. He unsuccessfully tried a second career in Paris. It didn't work out. I suspect the French were taking revenge for Descartes. So then we have another famous name on this list. I hope the Dutch will recognize at least. Simon Stevin, also an inventor of many things, including the decimal notation. It seems an easy thing, but you've got to think of it for the first time, and he did. And he also invented many much more enjoyable things. For instance, this contraption that you see here, which I probably should pronounce as the sail wagon. In those days, not selling beer, but nevertheless, a very enjoyable ride on the beach. So we can thank Simon Stevin for this particular contribution. Here's another famous Dutch applied mathematician that I suspect maybe even the Dutch may not have heard of. His name was Rudolf van Keulen. And he is actually sort of a computational mathematician in early days. He's mostly famous for calculating the 35 decimals of the number pi. And if you don't believe me, you can go to a church. You see on the right a pillar in the church in Leiden, the Pieterskerk. And if you look very carefully, you see those numbers around that circle, the first 35, without a single mistake, an accomplishment as such. So Rudolf van Keulen, small but significant applied mathematician. Here's another example that I hope the Dutch will recognize, a prominent politician, Johan de Witt, who also was the father of actuarial mathematics, the mathematics of insurance. Unfortunately, he was also the only actuarial mathematician who was the victim of a political assassination, as you can see on the right. All the more sad if you realize what his specialization was. But nevertheless, that is how he went. So, other than that, he had a splendid and extremely successful life. Then, this is a mathematician, another Dutch mathematician, that I suspect will be very well known to some of our speakers, because Korteweg in 1895, much later, proposed a mathematical model for the waves, oscillation of waves on shallow water surfaces. And this, of course, every presentation here tonight had one mathematical equation. This is mine. So I won't even try to explain it. I just want to mention that Korteweg did this work together with De Vries, and nobody has been able to find out who De Vries was. It's also the most common Dutch name, so it's not that surprising. Nevertheless, the two of them did it, and made history in doing so. And again, I suspect, for instance, that Luke and Kate are very well aware of the Korteweg-de Vries equations. Just a few more. Here is another famous, much more recent Dutch applied mathematician, Aad van Wijngaarden. Now we get into the category of people that some of us actually have met. So I have met Aad van Wijngaarden. He died in 1987. He invented a legendary programming language called ALGOL 1968, and he invented it, as you may have guessed, in 1968. And you see here his face and his portrait, and you also see here that Dutch are very good at chairing big committees, because that is what Van Wijngaarden did extremely well. And finally, to wind up just this small sample, here we have another famous Dutch applied mathematician who died unfortunately in 2002, Edgar Dijkstra, who, for instance, invented a very, very famous shortest path algorithm that many of you will recognize, but also was the father of structured programming. And he not only was a very good mathematician, but also one that liked to be quoted. And one of the quotes that he made that I like best is when he said, "Mathematicians are like managers. They prefer improvement over change." This is something you want to think about, perhaps. So, this is the list of Dutch applied mathematicians, and I hope that it has convinced you that SIAM is here for the right reason, if you're not informed, at least impressed. But, and you will forgive me by not extending the list further, and you will also forgive me for observing that what makes mathematics so special is, first of all, there's so many special mathematicians, like the examples that I've shown, but the discipline itself is also very, very special. And I now want to talk about the miracles of mathematics. And actually there are at least three. And this is really the first miracle of mathematics. And this is the first time that it becomes helpful to have this huge screen. Because all of you can now look at this the map of mathematics. all the mathematicians here can see if their own pet topic is somewhere on this map. And if it isn't, that just illustrates my point. Mathematics has just grown beyond recognition. People like Descartes and Huygens could easily overview whatever the mathematical universe was in their days, but of course nobody can even get close to doing that today. And his successors, and there are many of them in this hall right now, can simply not avoid some kind of super specialization, some very small domain on this very huge map, and that map that is growing day by day. Every mathematician recognizes the size of this domain, and of course what is so nice about mathematics is that something that is true at some point remains true forever. This is a handicap that physicians and others have to face up to, but mathematicians, when they have realized something is true, then basically they can stick to it for the rest of their lives and beyond. So it is a huge discipline, and it is still growing, and there are all sorts of developments that all of you are aware of in technology and beyond that will ensure its ongoing growth. This is a huge, huge discipline. First miracle. The second miracle is what some speakers have referred to, and which I would like to refer to as the beauty of mathematics. It really is a beautiful discipline, but in a very special way. And nobody ever said it better than Bertrand Russell. So while you are reading this particular quote, you will realize, I hope, certainly if you are a mathematician, its truth, because mathematics is beautiful in terms of its results, for instance, in terms of that beautiful picture on the top right, and there are many like those, as I'm sure you know, but also in terms of its method, in terms of its proofs, in terms of its notation. It has a very particular, profound beauty. And that beauty, as Russell puts it so nicely, that has something sublimely pure, a stern perfection, a beauty that is cold and austere. I think that summarizes it very well. And sometimes perhaps a bit sterile, but nonetheless, as a whole, very convincing and a very integral part of this very special, special discipline. So the beauty of mathematics is something that I think especially mathematicians are well aware of. It's very hard to convey, it's hard to explain to others, but I think we all recognize. And I hope that some of the non-mathematicians here sense vaguely perhaps its truth and its significance. So mathematics then is a very beautiful discipline. The third miracle of mathematics, I think, is what you might think of as the efficiency of mathematics. And there the most famous quote, perhaps the most famous quote all over on this particular topic, is the quote that I'm giving you here for Eugene Wigner, a Nobel Prize winner, who said the unreasonable efficiency of mathematics is a gift we neither understand nor deserve. I think it sums it up very nicely, because it has puzzled people over the ages why mathematics is so enormously useful. How is it possible that this very abstract structure embodies the real world in a very profound sense? How is it possible that the real world creeps into these theoretical abstract structures and then yields all these surprising dividends, these surprising applications? So one of the speakers said, at some point all of a sudden you realize that a certain piece of mathematics is enormously useful, and 50 years nothing happens, and all of a sudden that same piece of mathematics is very useful again, in a very different domain. It is a miracle. Of course, people have tried to explain it. Philosophers have loved to try to explain it. Mathematicians have generally ignored those philosophers. They just continue to do mathematics and enjoyed the benefits of this very, very puzzling and deep connection. Yes, mathematics is unbelievably efficient. It delivers from day to day, and tonight we've seen wonderful examples of the various domains where that efficiency, that applicability shows up in many surprising senses of the word. So here we have the three miracles of mathematics, if you will. But in fact there is a fourth one. And the fourth one, I think, before I get to that, let me just quote and and demonstrate the efficiency of mathematics on this slide that I had overlooked. But this slide is a very Dutch slide, because the Netherlands is such a small country that people here can actually compute how useful mathematics actually is. And they did. And so there is this consulting service who came up with the outcome. It supports about a quarter of all the Dutch jobs, and it supports about 30% of gross value produced in the Dutch economy. Now again, this is a huge screen. You can look through all those numbers if you wish, but I think you might be happy and ready to believe that this is more or less what it says. Mathematics, again, is unbelievably efficient. It really delivers, and it certainly delivers for this country. What is the fourth miracle of mathematics? The fourth miracle of mathematics, I think, and that is where I will complete my presentation, the community of mathematicians, the community that has been represented here during a large part of the week by this very large group that has come to Amsterdam, but it of course assembles on a daily basis all over the globe in all kinds of different configurations. And I think it's fair to say that in terms of scientific communities, the community of mathematicians is really unusual in its generosity, in its openness, and in its general and generous interest in others. It really is a meritocracy as pure as meritocracies can be. And in mathematics, within the community of mathematicians, it is not so much your table manners that matters, it's not your friendliness that matters, your pleasantness to be interacted with or whatever. It's simply the extent to which you are open to listen and ready to contribute. And that community of mathematicians globally, with so many thousands, tens of thousands of participants, is, I think, yet another enormous miracle, a miracle that we should applaud and cherish. And it is not hard at all to be accepted by a group of mathematicians, even if you are not a mathematician yourself. And I think that is now something you are about to experience over the drink that you have so much deserved, the speakers and the listeners equally. And while we are all looking forward to SIAM's next visit, hopefully again to this country, but let's be realistic here, to Europe perhaps, let's at least enjoy that perspective, and let's also make sure that we engage in these conversations, these open conversations that mathematicians are so famous for. And here I have some final word of advice for you. There is one opening sentence that will always get a mathematician going, wherever you go and wherever you are. And that is this particular sentence. So keep that in mind, and I can assure you, over a drink, whoever you talk to, if this is your opening question, you will get a reply that will lead you to listen, wonder, and learn. Thank you very much.